we're going to use displacement and mental rate. So the first thing I'm going to do is go to my rendering. So I'm going to choose rendering, render, and I'm going to set mental rate as my renderer by going down to assign renderer. Or another way to assign mental rate as a renderer is to click on the preset and choose mental rate no global illumination high. And here, just to make the render go faster, I'm going to go to renderer and set the minimum sample size to 1 and the maximum to 4. That would give me a bit of blurriness in my rendering, but it's important for me while I'm testing my scene. But later on, whenever I want to have a full render, I would choose 1:16 or preferably 4:16, which would take a bit to render. But for now, I'll just go by 1 and 4. I might also go by 1 and 1 if I find that my scene is rendering slowly. If I create a sphere and I open my material editor and assign a material, and I go down to maps, displacement would create rough geometry with high detail according to a grayscale map. So this grayscale map that I'm going to use now is a mix of several maps. For simplicity now, I'm going to go to displacement none, and I'm going to add a noise map. And I'm going to render this. So this is the displacement, default displacement that I get out of the sphere. Now I'm going to go to modify and reduce the segments of my sphere, because the high detail will be obtained from the displacement. I'm also going to choose fractal. When I choose fractal, I get higher detail. So instead of having to add a million segments to my sphere to get this detail with the noise modifier, I add a displacement map. So now if I go to my levels and increase those, I would also get much higher detail, because whenever you increase the levels, you're going to get a lot of detail, a lot more detail. Now, if I want to create even more detail for this, this is what I would do. I would take this noise map and drag it down, for example, here, and choose copy. So now I have a noise map inside my existing noise map. If I go inside the inner one and reduce the size, say to 5, I would get more detail because I have a big noise map with a smaller noise map inside it. So now, if I want to reduce the effect of the smaller one, I would take this white color and make it darker, because the displacement map works according to the contrast of these two colors. So if the two colors were far apart, I would have a lot of displacement. If they were close together, I would have less displacement. Now here, this is rendering fine, except for the fact that I have a little problem in case or actually let's try this, maybe you don't have this problem. Okay, now this is something that not everybody notices, but I have a little problem here at the pole of my rendering. So if I go to rendering and show last render, here I have this little pole, or actually there. If you don't want to have it, instead of creating a sphere, you would create a geosphere. Because the geosphere does not have any poles. It's symmetrical all throughout. But the sphere does have a pole, and therefore you're going to have this little artifact. So to remove that, but this is something that not everybody notices easily. But in case you want to be a perfectionist, you would create a geosphere instead of a sphere. And now your displacement will not have any poles, and it should be properly displaced all throughout. So this is the advantage of using displacement maps. Now here I'm gonna go to parent to go back to my original map. I'm gonna uncheck show end result, and this is my displacement map. So the white colors are displaced and the black colors are not displaced. And since I placed a small noise map inside the big one, I get these little dots which add to my detail. Now in case I wanted to dramatize the effect even more and get more separation between the white and the black colors, I would play with the high and low values. So the closer they are, the high and low values, the more contrast I'm going to have. And the more contrast I'm going to have, the more dramatic is going to be my displacement. So now I get more protrusions from the displacement map. So if I uncheck this, just to work on the bigger map, this is how I would dramatize the effect, by making the high and low values closer to each other. So the closer, the more contrast I'm going to have in this map, and therefore the stronger is my displacement, because these parts are going to be really low and these parts are going to be really high. But once I start to have these white splotches here, I'm going to have flat surfaces in my displacement. So it's not advisable to have these white effects. So I would reduce them by upping the high value and maybe lowering down a little bit the low value, just to create more blending. So you don't really memorize these values, you just change them until you get the effect that you're looking for. If I want to tone down the small displacement, I would go here and I would darken up the gray color so that the small ones are not really affecting my surface. Now what I want to do here is create the effect that I have two different colors for the upper part and for the lower part. So the high part of this rock should have a color, and the low part, the trench, should have a different color. To do that, I just drag this map to my diffuse color channel and choose copy. And let's uncheck this for now. And now, just to visualize the effect, I'm going to select a yellow color and a dark brown color here. And see what I get. So now we see that the low parts are yellow and the high parts are brown. So if I want to increase the contrast or make the brown more pronounced, I will play with the high and low values to reduce the orange and get the brown to shine more. So now, whenever I render, I get more separation, and I keep working on this until I get the effect that I'm looking for. Okay, so once I have the proper separation, I would make this even darker. I would go to parent and drag this down to my self-illumination channel. And what this will do is light up the rock according to these colors. So I'm going to set my yellow color to bright yellow and the other one to pure black, so that only the rock part will glow. Now to dramatize the effect, I go down to the output. So let's go to my diffuse color here. I go down to the output and increase the output amount. And what this will do, let's render this from a distance so that it renders faster. What this will do is emphasize the glow of these colors. So now I see that the yellow is shining really strong. So here we learned how to use displacement with mental ray and how to create a dramatic material using self-illumination and diffuse coloring in addition to displacement. What I'll do first is model the RBC. So I'm going to go to extended primitive and choose chamfer cylinder. And create a chamfer cylinder like this. I'll go to modify and play with the fillet value and increase the cap segments, and also increase the fillet segments to have it more round. Now I would also increase the sides, but I'm not going to increase them too much because I'm going to see these from a distance, unless I want to see them from the camera, close to the camera. What I will do now is add a groove at either side of my RBC, because this is the way an RBC looks like. So to do that, I will add an edit poly modifier and choose vertex and select these vertices. So now the top and bottom central vertices are selected. So I'll press F3 and go to soft selection, use soft selection, and choose shade the faces so that I see exactly what's being affected, and I'll increase the fall off. Now if I right click and choose scale and go to use selection center and scale down, I would get the required effect. So now if I exit this, I get the groove of the RBC. So here, to render this, I'm gonna press M, assign the material and call it RBC, which stands for red blood cell, and I'll assign the material. Now first, the diffuse color should be of course red. Now I'm gonna go to maps, bump, and add a noise map and render this. I'm gonna set the size to 3, or let's choose 5. Now the trick here is to go to my diffuse color and add a fall off map. Now whenever I render this, I get the proper shading that is obtained from an RBC, and here I would set the dark color to red. So now when I render this, I start to get the shading that is required, but still I have to, let's try the Fresnel effect here. The Fresnel effect would reduce the effect even more, so I would better go back to perpendicular parallel and add a point here, and if I look up here, if I drag the point, the center point down, the outer part is going to be less white. So here I can play with this value I right click here and choose Bezier smooth so that I get a smoother curve for the transition. If I put this point up, I would emphasize more this color. So now if I take another fall off map and place it inside the red color so that I have a darker red and then a brighter red, that way I would layer up my, here I'm gonna delete this point. I would have a transition between dark red to brighter red to white. I swapped the colors, yes, to have the dark red on the inside. So now I'm gonna go to parent and reduce the bump amount. Now if I want to again create something a bit more dramatic, I would drag this down to my self-illumination channel, and that way the white parts will shine even more, and this will make it look a bit more organic. Okay, and here maybe I'll make it a bit brighter. So the final material is something like this. It's bright on the outside and dark on the inside. which is the way you would see an RBC using a microscope, electron microscope. So this is my rendering for one RBC. Now the first thing I need to do is create these splotches in Photoshop. So I'm going to switch to Photoshop and I'll create a new file. Let's say 600 by 600, although the bigger, the better the resolution. Now I'll press Ctrl I to convert everything into a black surface, and I'll create a new layer. Now here I need to draw the water drops, so I'll use the lasso tool and add to my selection to create the different traces. You can have as many as you like. Okay, so once I have this, I need to save the selection because I'm going to use it later. I can either save it from here, or I can go to channels and add a channel. Now here it's going to be the alpha channel, which I don't really need being an alpha channel, but I need to save the selection, so I'm going to keep it over here. And then I'll go back to my layer 1, and I'll fill this layer with the foreground color. Now I'm going to deselect, and I'm going to choose blur to blur out the splotches like this. Now in case I would use this texture as it is in Max, I'm not going to have the borders, the definite border for my water trace. So what I need to do is go back to channels, press Ctrl and click on the alpha channel to regain my selection, and go back to layers and then inverse the selection and delete. What this will do is create the depth effect. So the outer parts have a definite edge, which will create the edge for the water splotches, and I have a fading effect to the outside, which will make the inner parts deeper than the outer parts. So, and the small parts, you see that they are gray and not pure white, which will create the effect that I'm looking for. So once I'm here, I'd save this as a JPEG. It does not need to have an alpha channel because I'm going to use it as it is. And I'll go to Max. Now the first thing I need to do is create a masking effect that will reveal the reflection according to the white colors that I used in Photoshop. So here the white color will be reflective and the black color will not be reflective, and the gray color will be halfway reflective. So I would go here and go down. First I'm going to reduce the glossiness to 0. I'll go down to maps, and where it says reflection, I'll click and choose a mask map, which is here. Now I have two maps here. The map, which is the reflective map, in this case it's the ray trace map, and the mask, which is gonna reveal that reflection according to a grayscale map. So for the map, I'll choose ray trace, and that's it. Go to parent. And for the mask, I will choose the map that I just created in Photoshop. So I'll click, choose bitmap, and select this one. If I choose show map in viewport, I will see that map here, and the white areas are going to reflect eventually. So if I render this now, I will not see the result properly because the map, whenever I apply it to the reflection channel, and remember that this is applied on the reflection channel, will be by default an environ map, which is mapped onto a huge sphere and not on the actual geometry. To map it on the actual geometry, I have to choose texture. So now when I render, I see the reflections where they need to be, which is wherever I have the white areas. So now I'm gonna go to parent, and I'm gonna work on my diffuse color. So I'm gonna, in the diffuse color, I need to have the regular wood material and the darkening of the wood according to that map that I created in Photoshop. So I'm going to click on diffuse color, and this time I'm going to choose mix, which will mix between two maps according to a third map. The mix map mixes between two maps or two colors according to a third map. Now this third map is definitely the map that I created in Photoshop, which is what's going to mix between the two. So I'll go to parent, and here the first map is going to be my wood map. So I'm going to select this map here. And the second map is a darkened version of that wood map, which is obtained using the following technique. Of course, you can go to Photoshop and create another version, but that would make your work, that would take longer to do. So what I would do here is drag down this map and choose copy. So now I have two maps having the same exact colors. So the mixing will not be any different. What I will do though is go to the second one and click on bitmap, and this time select RGB multiply, which will multiply or darken up the RGB values of that map. So I'll double click on it and choose to keep the old map, which is this, the wood map, as a submap. I can either multiply it with another map or with a color. So I click here and choose a darker wood color. And if I look up here, I see the result. So I'm going to go to parent and uncheck reflection just to test on the RGB multiply color. So I'll render now, and I see now that I have this darkening effect, which is gradually fading inwards, which is exactly what I'm looking for. So one thing I can do is right click in my virtual frame buffer, sample a color, and drag it down here to have the exact color as the wood, and render, and this will make it look better. So now that I have the darkening, I would go to parent and enable the reflection and tone it down a little bit, because water does not reflect at 100%. So here, this is reflecting the black color, and these are reflecting this. Now what I need to do at the end is create the bump effect. So I would go to bump, and here I would choose browse from material editor and select my map, or I can just press new and bitmap and select the same map from before. So selecting this map and rendering would create the proper effect for me. We're going to see how we can use the density of the fog in a ray trace material to simulate depth in a volume of glass or water. So first I'm going to create a box, and I'm going to set my environment color to white, and of course I'm going to render. I'm going to get this. Now here I don't have to use Mentoray because this works with the scanline renderer as well as it does with Mentoray. So just with the regular scanline renderer, I got this now. Now I reset these to normal. Okay, so what I'll do is add a ray trace material, which I will assign. Now I'm going to set the diffuse color to pure black, so I can play with the transparency color and have this color not interfere with the diffuse color. Because I want to create a transparent material, my diffuse color should be set to black so that the color of that material will be derived from the transparency color. So I'm going to increase that transparency color and render this. Now the brighter, the more transparent. But so far everything is going to be even because I don't have any fog set inside this. So I'm going to set this to close to white. And now I'm going to go to extended parameters. And here I'm going to check the density for fog. And this is the color that I'm going to use. So if I want this to be bluish, if I was doing a water surface, I would select a light blue color, and here I would render. And here I start to see that I have a volume inside my surface. So I'm going to set my transparency to pure white so that I get just the color of a volume, although I can change this later. And now, this distance is the distance from 0 density up to 100% density. So if I want this to be darker water, I would go here and make this darker. And this is the distance that I can control. So if I increase this, say, to 57, I'm going to have a bigger distance where I'm going to transition from 0 density to 100% density. Now, to make this look even more realistic and make this look like a real water surface, I'm going to first, instead of having a box, create a chamfer box, because the chamfer box will give me curved edges. Assign the same material, and what I will do is go to bump and add a noise map for the bump just to simulate some waves on the surface of the water, and I'm going to set the reflection type to Fresnel. So now whenever I render, I'm going to get a real water surface with degrading or increasing density whenever you go inwards. And here I would saturate a little bit this color and make it darker to simulate depth. So this is how I would create a water surface with depth. Now to test this, I'm going to add a cylinder inside to see if this fades in with the depth of the water. So when I go here, I'm going to give the cylinder a yellow color to be able to contrast it with the rest. And I'm going to render. And here I'm going to see that the cylinder will fade out in the water surface. Now to see this better, I'm going to uncheck reflection so that I just see the refraction, because I want to see if this fades out, and this clearly fades out with my water surface. So if I look at it from another side, so let's lower this down. So here, because of the fog effect, I don't see the cylinder, and this fades out gradually according to the density that I give it. So if I want to control this value, I would go down and play with this amount here. Now I want this to look like an old house that has old rough materials. So I'm going to create a new material called walls, and I'll assign. Now I'm going to go to my diffuse channel, and I'm going to choose to have a smoke map. And I'll render this. What the smoke map will do is create a pattern that I have over all my geometry. Now, since the smoke map is procedural, it will not take into consideration the size of the object. So an object that is bigger than another one, let's say a bigger wall than another wall, the map will not stretch according to this size, because this is a procedural 3D map. So I don't have to worry about applying UVW maps or anything. Now, the first thing I'll do is increase the size, say to 90 here, and hit render, because I don't want this pattern to be very visible, because I need to have some soft darkening over the different parts of the walls. So I'm going to go like this. Now the exponent value here will increase or decrease the contrast. So if I decrease the exponent value, and if I uncheck show end result, I'm going to go more towards the bright color. If I increase it, I'm going to tend more towards the dark color. So I want them to be close to each other, so I'd go with a value like this. So now I start to see that I have cracks over my wall, which will be a good thing to have to simulate cracks using this and bump mapping. So let's go a bit more to see what we get. Let's go to 0.3. Alright, so this is a bit more realistic. So now, whenever I have, or wherever I have the white areas, I'm going to add a different map. So here, under white, I'm going to click and choose, say, a noise map. Okay, and render. So now, instead of the white areas, I have the noise map, which is here. So I'm going to go and create two colors which are slightly contrasting like this. And I'll set my noise type to fractal and up the levels. Now I still need to increase the size, but this is already giving me variation. So I'm going to increase the size, say, to 50. Now the trick to get realistic materials is that no material in life or no surface has one color only. In this case, I have three. I have white, brown, and black. But surfaces in reality have a multitude of close colors. So you have to simulate this richness in colors to get realism. So instead of having this flat brown color, I'm going to drag my noise map down here and choose copy, not instance. Because if I choose instance, they're going to be exactly the same. And I want to change them. So I'll choose copy and go to the inner one. And here, I'd create a variation on this color and something like this. And here, I can change the size and also play with the offset in X, Y, and Z so that I don't get the exact same noise map. So when I render, I get yet another color inserted within the brown one. So I don't have one brown color now. I have brown and pinkish. So let's decrease the brown and lower down the saturation. Okay, so that's what I get. This is what I get now. And I'm going to go to parent, and I'm going to do the same for the white one, because the white one is still flat. I have broken down the brown one, but the white one is still flat. So I'm going to go to the white one, and this time I'm going to choose a splat map. The splat map will give me dots. So wherever I have the white color here, I'm going to have dots to fill up that area. So I'm going to press OK, and the dots are the color number 2. So if I want them to be dark, I would make this color dark, and the other one is going to be, let's say, brownish, to see what it gives. Okay, so now that I get the dots are very big, so I need to scale them down by reducing the size, say to 4 or 3, because they need to be very fine dots. Okay, now if I want the dots not to be so sharp, because so far they are sharp, here I have a camera view, so I'm going to press P so that I can zoom over, and whenever I regain my camera view, I would press C. So here, I would zoom over. I'm going to look here at the map. If I look at the threshold will define how many dots I have. So the higher the threshold, the more are the dots. So I'm going to go to 0.15, and instead of having a sharp color for the dots, I'm going to add a noise map, and this will break up the dots even more. So I'm going to go in and choose noise and fractal and render this. So now this will soften up the dots and give them more color variations. So if I go here, I can swap the colors so that I get more black instead of getting gray, which is something like this. Okay, the last thing I would want to do is break up this color because it's still flat. So I'm going to select it and choose this time, let's say, something that will not be very contrasting. So let's choose another smoke map here and add 2 dirty colors, something like this. Okay, here I'm working on this. So if I want to see more contrast, I would darken up one of the colors so that I get more detail. Now, I don't want to have too much contrast, so I'm going to increase it just a tad more. And that's it. Now, all of this is going to add to my bump map. If I look here at the striations that I get, this will be used to effect with the bump map. So what I will do now is go to parent a few times, because I have a complex map here. If I click here on the navigator, I will see what I used. I used a diffuse color map, which has smoke. Inside it, I have noise. Inside that noise, I have a noise and a splat. And inside that splat, I have smoke and noise. So this is the tree of your material here. You can also click here to see the different maps that you used and how they are combined together. So once I'm there, I'm going to go to parent a few times and then go down to maps and drag all this down to the bump channel and choose copy and give this a render. So here, since I'm not using pure black and white, the bump is not going to have a strong effect unless I up the bump amount. So first I'm going to uncheck diffuse so that I only get the bump, and I'll regain my camera view and I'll add an omni-light in the center to observe the bump effect. So all of this now is coming from the bump map. Now, if I go to my bump and reverse the values, in this case -20, I'm going to have the inverse direction. So these will go inwards. And this is now starting to look like an old house which has been deserted for some time. And adding to that now, the diffuse color will give me this. I switch to mental ray, and what I'm going to do now is go to the opening and I'm going to go to lights, and here I'm going to use mental ray area spot, and I'll create that here, which is at the door. Now an area light is a light that emits light from a surface rather than from a point, because in reality no light ever comes out of a point. So you always need to have an area light. It can be spherical, it can be rectangular, it can be in the form of a disk. But the important thing is that it needs to be in the form of a surface. In this case, it needs to be rectangular because the opening is rectangular. Now to see the extents of the lights, for mental ray to show you the extents, or for Max to show you the extents of the lights, I need to select the light, go to modify. Here the shadow types are going to be set to ray trace shadows. I would go down to area light parameters, and here I'd make sure that the type is set to rectangle. Now I'm going to increase the height, and while I do increase the height, I'm going to see the extents of the light. Whenever I release the mouse, I'm going to lose that. So I'm going to press P and go here. I'm going to press Control L to see the normal default light viewports, and whenever I increase with the spinner, I'm going to see the extent of the light. So this is the height of the area light. I need to select this light and put it here in the center, somewhere around there. So again, if I go here and play with this, I would see the extents of that light. And I'll do the same for the width. So here it's important to center your light to the opening, which is around here actually. Okay, so if I increase the width, I would see the extents of that light. Alright, doesn't have to be perfectly precise, but something close. Okay, so having done this, I'm going to zoom out, press C, and give this a render. Now to make things go faster with the rendering, because whenever I use bump maps, mental ray becomes slower. And here I have a lot of bump maps. So to make things go faster, I'm going to give everything another material, and then we're gonna continue with the normal materials. So for that, I'm gonna go to rendering render. I'm gonna go to processing, and I'm gonna click on material override enable, and I'm gonna press M. This will override all the materials of the scene with one material that I choose, and this is very useful whenever you are testing your lighting. So all the materials will be overridden by this material that I'm gonna choose. And whenever I want to go back to my original material, I can disable this material. So I'm going to choose standard, And if I want to edit it, I would drag it down here, and I would call this override. And I'd go like this. And now if I render, I'm going to render with this material so that I can test the lighting properly. It renders much faster right now. And at the end, if I want to go back to my original material, I would uncheck this and I would render with my normal materials. Okay, so this is to speed up your rendering whenever you are testing your lighting. So for now, I'm going to enable it. Okay, now the problem with the area lights is that in reality they are not real area lights. Even the Mental Ray area lights one, they are not real area lights. They are lights that generate area shadows. So there's a difference between a real area light and an area light that generates shadows. So here, if I render this, I'm still going to get the light coming out from a point, but the shadows will be coming out from a surface. So this is a limitation with Mental Ray, and hopefully it's going to be resolved soon. But for now, before it gets resolved, we're going to select this light and increase the hotspot so that it covers the whole opening. Something like this. So we're going to set this to a value of around 0.8 or 0.9. And then we're going to start putting OmniLights inside here. So instance and go up. And here I'm going to use decay, inverse square, show it, and go like this. So let's see what we have now. And since I have a bluish skylight in the background, I'm going to make this slightly bluish and render. Okay, so now since I'm not using any shadows, the light is affecting the whole area. So what I will do here is use shadows, and here I'm going to use Mental Ray shadow maps because these shadow maps are optimized for Mental Ray, and I'm going to decrease the extent of the lights. And of course, I need to tone down their multiplier. So I'm going to make my background color white, pure white. I'm going to tone down the decay. The light that's coming through is coming through that light here. And this light is going straight in, so I'm going to take it and make it go up. And here I'm going to go to Fuse and choose the spotlight and press F3 to see what I'm hitting. So in this case, I want to hit that area or maybe that area. So I turn it to affect the area I want to affect. Let's delete that light because this light is lighting up the dark room here, and I want it to stay dark for now. So now I'm going to start playing with the lights on the inside. Now this part should be the darkest, and the rest should brighten up accordingly. But since I'm using colored walls, the lights should have colors similar to that wall. So I'm going to create an Omni here, create a copy, which is an instance, move them down, and create another two. Place these here, and place these up here. And of course, I'm going to make these a bit brownish because of the color of the walls. And I'm going to tone down their multiplier. And I'm going to use decay. I'm going to go like this. And I'm going to use shadows. Now, in this part, I'm going to select these lights, press Shift Move and go here, choose copy, but there will still remain instances with respect to each other. And I go like that. I have to choose a mix between blue and brown, which would give me something like this. Okay, and I can uncheck the show the decay. Whenever you have multiple lights selected, you have to check the show so that you can see it. Otherwise, you won't. So this multiplier would be around 0.2, and this is around 0.08. So let's see what that gives. So to make the scene come more to life, I'm going to give these a bit more color. So let's make them slightly more bluish. And put these lights to the front so that the brightest would be close to the stairs. And maybe tone these down a little bit more. So let's say 0.06. Okay, so now I'm going to go and activate my original materials. And I'm going to hit render. Now, what I still need to do is brighten up the whole scene globally, because it's still a bit dark. In this video, we're going to create soft reflections with Mentor Ray using the DGS material. First, I'm going to create a box, which is going to be the floor. And I'm going to open the material editor, and I'm going to select a Mentor Ray material. Now, under basic shaders, next to surface, I'm going to click none, and I'm going to choose DGS. DGS stands for diffuse, glossy, specular. And these are the three map types that I can have here. And I also have other parameters like shiny, transparency, index of refractions, and lights. What I need to do first is assign the material. And under diffuse, I'm going to click on bitmap. And I'm going to select the map that I'm going to use for my wood texture. So I'm going to select, this one. I'm going to turn it, so I'm going to go to W and rotate by 90 degrees. And let's give this a render. It's a bit too big, so I need to scale it down. So I'm going to increase the tiling to 2 by 2. And I'm going to reduce the samples now and the virtual frame buffer. Okay. So now I need to give this a bump map. So I'll go to parent twice, and then under extended shaders bump, I'm going to click on none, and I'll choose bump 3ds max. And here I need to use the same map that I had for the wood. So I'm going to click on map, and I'll choose browse from material editor, and this is the map that I'm going to use. So double click and choose instance. Uncheck the diffuse map in the surface because I just want to test the bump map, and rendered. I will see that I have the bump effect on my surface. I would increase a little bit the samples so that I get a better resolution. So this is how I would add a bump map to my Mentor Ray material. So now I can check the color, and now I have both the bump and the color. Of course, I can go here and change the bump multiplier. So if I go to -1, it's going to bump in the opposite direction, which is move the dark areas up. But of course, it's not what I want, so I'm going to stay at 1, which is pushing down virtually the dark areas. Okay, so now I need to create, first of all, perfect reflections and then soft reflections. So I'm going to create a box here, and I'll go back to my DGS material, and here I will set the glossy highlights to pure black, and increase the specular color to light gray. Whenever I do this, I'm going to have perfect reflections, which is a reflection that is not soft. Now the reason it's degrading down is because of the bump map. So if I go up and uncheck bump and render, I'm going to have a perfectly straight without any softening. So the bump map is one way to soften your reflection. The smaller the grain size in the bump map, the more soft is going to be your reflection. But this is not the way we're going to use the soft reflection, but this is just an observation on this phenomenon. Now, in case I want to tamper with the amount of reflection, if I increase the brightness of this color, the amount of reflection is going to increase. So if I set it to pure white, I'm going to have a very strong reflection, which is not typical for wood, of course. For wood, I would have a much softer or much dimmer reflection, something like this. Now, in the case of wood, the reflection is never so clear, so I need to diffuse it out. For that, I need to use the glossy highlights and not the specular. So the specular is to create perfect reflections, and the glossy highlights is to create soft reflections. So I'm going to, of course, I can combine both, but now just to test what I have, I'm going to set back the specular to pure black and therefore get no reflection whatsoever. But I'm going to go to my glossy highlights and increase the glossy highlights, and this will create a soft reflection. Again, the color or the brightness of this gray color impacts how strong is the reflection, but not how soft is the reflection. To make my reflection softer, I need to play with the shiny value. The shiny value is inversely proportional to the softness. So if I decrease the shiny value, I'm going to have a softer reflection. If I increase it, I'm going to have a sharper reflection. Let's increase it first to 80 and render. And here I see that I have a sharper reflection. If I decrease it, however, to 10, I'm going to have a much smoother reflection, but keeping in mind that the start is still the sharpest point in the reflection. So if I go down to 5, I will start to get the real reflection that I get with a typical wooden surface like this. And of course, playing with the brightness of this color determines how strong or dim is my reflection. So this is the way to use mental array to create soft reflections with controllable brightness and softening amount. In this video we're going to discuss how we can assign opacity maps to objects and have these objects cast shadows according to the opacity map. So we're going to do it for a very simple example, but this can be applied to objects with any type of textures. Here I have two planes. I'm going to go to Photoshop and I'm going to create a new file. I'm going to set the background color to black and I'll create a new layer and I'll draw a simple tree. Now of course this can be the picture of a real tree or any other object, but in this case I just want to draw this very simply. I'm leaving some holes on purpose to see whether they can cast shadows or not. So I'm going to save this version of the image as a JPEG. I'm going to call this tree color. Next, I'm going to press Ctrl and click on the layer to select the contents of that layer. I'll create a new layer and fill it with a white color, like this, and choose File, Save As, again as a JPEG, and call this tree opacity or OP. So now I'm going to go to Max and I'm going to open the material editor and assign the material to this plane. I'll go to my diffuse channel, choose bitmap, and select the tree that I just created. Go to parent and then go down to maps choose opacity, bitmap, and select the tree opacity again. And now I'm going to change the background color so that I know whether this is working or not. So I'm going to set it to gray, and I'm going to increase the size of the plane a little bit. So if I render now with max or mentor ray, I'm going to see that I'm just going to see the tree without the background. Here I have a little border that I still have. If I zoom over, I see it here. To solve the problem, I would apply a UVW map modifier and make sure that the projection is set to planar. So now whenever I render, the problem disappears. Because before, the projection was set to box, even though I didn't have a UVW map modifier, and I had the same image projected on the very thin width of the plane, and I had this little line showing. So when I set the projection type to planar, it will go away. Now, if I create a light that would shine down on the object and choose to have shadows on, I'm going to have the shadow to have the dimensions or the shape of the plane without taking into consideration the size or the actual tree. To make it work, I would go to modify and I would set my shadow type to ray trace shadows, both in max and in mentor ray, and I would have the shadow take exactly the map that I have in the opacity channel. So here I had two maps, one in the opacity and one in the diffuse channel. I can use the same map in both in case I had an alpha channel for the map. So if I go to Photoshop and I press Control click to copy the selection here and went to channels and created an alpha channel and fill this up, and then I would have to I would delete this, and I can also delete the background. So here I can save it, but not as a JPEG because JPEGs do not support. So I can either use Targa or TIFF. I'm going to use TIFF now, and make sure that alpha channel is checked. I'll call this tree 2, for example, and save. Here I have to make sure that save transparency is on, and I would discard any layers in case I had layers. So I'll go to max. I would select a new material, which I would assign, and I would select the map. I go to parent and I drag this to my opacity channel. Here I click to see the checkerboard behind. I'm going to go in and set the input source to be the alpha channel. Now here, if I middle click on the mouse, I can turn the object around, which is the sphere here, to see whether it's transparent or not. So now, if I render, I get the same result with just having one map, which is a map that supports an alpha channel, used in both the opacity and in the diffuse channels. In this exercise, we want to talk about subsurface scattering, which is a way to simulate real skin for a character or a translucent object like a candle, for example. We're going to start with applying this to a character, and then we're going to apply the same logic to a candle. Max supports different kinds of subsurface scattering, and they are all available within Mentor Ray. So the first thing I'll do is select the object and open the material editor. And instead of having a standard material, I'm going to choose fast skin material. SSS stands for subsurface scattering, which is a way to simulate light going through skin, like a human skin, for example. So I'll double click, and right away, if I render, I'm going to see a difference with the default render. So the first thing I notice is that I have a very soft and diffuse look for the skin now, and it almost looks like wax, which is the appearance that subsurface scattering gives us. Now, if I take the light and I place it here, if I move the light to the back and render the character, I'm going to see that the thin areas, like the ears, are going to be more lit than the rest of the body. So here, if I zoom over, I see that this part of the ear is a bit glowy, and this is the typical effect of subsurface scattering. Now, it's best for subsurface scattering to use mental ray area omnis or area spots, because those will create the proper shadows for the effect. So I'm going to delete this and add a mental ray omnilight, and I'm going to turn my view now over here, because that will show more thin areas in the head than having to face it like this. So this will emphasize on the subsurface scattering effect. Now I'm going to place my light somewhere over here. So if I give this a render now, I would start to see the soft diffusion that I get from the scattering effect. So this is the effect that I'm looking for. I want to see the depth of the skin whenever light is hitting it in a certain direction. So if I take this and move it to the back, I would see a different result, which is the reddening of this area, because it's not directly lit by light. And the amount or the extent to which I get this effect can be controlled from the material, which is what I'm going to do now. So if I open the material now, these are the parameters that I need to adjust. I have two main settings that I can work with, which is the epidermal top layer, which is the outermost layer in the skin, and the subdermal layer, which is the layer underneath it. Now, if I want to make the effect deeper, first I'm going to increase the extent of the epidermal layer. So I'm going to go to 1 to give it more weight, and therefore this will make it more react more to light. And I'm going to increase the radius a little bit so that it extends a bit more. So I'm going to give it 1 again as a value. So when we render now, we should see more reddening here, but we're still at the epidermal level, but already we start to see more reddening in this area. So we're going to stop this, and to make the render go faster, I'm going to uncheck shadows for now. And now I'm going to work on the subdermal layer. So I'm going to go, for example, 2 by 2. The first 2 is for the weight, to make it more react more to light, and the second one is for the radius, to make it go deeper into the skin. So having done this, I should get more of my scattering effect. Now notice that the effect is also visible in the fingers, and now it's starting to get visible in the ear, even though the ear is not lit directly by the light. Now, whenever you turn or change the camera position, the effect is going to change according to that view. So it's not a map that's being applied to the object, but it's a volumetric simulation of real skin. So and the effect will be most visible whenever you have thin surfaces like the ears and the nose, and in this case, for this model, the eyebrows. So this will dramatically add to the realism of your characters whenever you're rendering objects with translucency like skin. So to get real shadows, which is very cinematic, you have to use, for subsurface scattering, mental ray, in this case omnilight. It can be, of course, spotlight with ray trace shadows, and you go down to the area light parameters, and here you increase the radius. So if I go to 10, for example, I would have a softer shadow here, and this effect is very much used in cinematic production to create dramatic lighting. And this exercise will explore the UVW unwrap modifier to see why it's used and how we use it, and then how we can make use of the UV coordinates created with the unwrap modifier to use the coordinates and paint over a surface in an external program like ZBrush. So the simplest example is to unwrap a box. So I'm going to create a box, and first, why do we need to unwrap it? If we open a material, or actually use a material, and assign it to the geometry. Here it doesn't matter if you're using max or mental array. So if we assign a material with a texture, any texture you like, let's say this one, and show the map in the viewport, we're going to see that this texture is projected at every face of that box. Now sometimes we need this, but sometimes we don't. We want the texture to complete itself over the geometry. So in case we had a straight line here that curves down and continues slanted down here, we want to see how we can create that continuity for the texture over the geometry. We don't want the texture to repeat itself over all the corners. So the logic I'm going to use for the box can be, of course, applied to anything else with a little bit more patience, because unwrapping is a tedious process and it requires a lot of repetitive manipulations depending on the complexity of your mesh. So what I'm going to do first is go to modify and apply an unwrap UVW modifier. The purpose of unwrapping an object is to convert the 3D representation of that object into a planar map, which we can use later to create the continuous map and project that onto the 3D object. So unwrapping is taking a 3D mesh and flattening it into a planar map, which can then be projected onto different faces. So the first thing I will do is go to edit, and here I'm going to see the polygons which are all stacked onto the same place in my unwrap window, which means that all of them have the same projection. Because all the polygons are stacked into the same place, it means that all of them have the same projection. Now the first thing I can do is take these, for example, vertices, and move them, and I would see that the image will distort over the geometry. So by taking the vertices and moving them around, for example, putting them down here, would be doing the same thing as cropping the image in the material editor. So now I took the projection of the polygons to be only that part. Now, the logic behind unwrapping the box is to give every polygon, and I have 6 polygons in my box, a different part of the image. It can be this image or any other image, such that the distribution of these polygons is continuous, and therefore I'm going to have a continuous flow of the image over the geometry. To do that, I need to give every one of those polygons a different UV space. This is my UV space. If I zoom out and take these out, for example, and uncheck the texture, this is the UV space. U stands for horizontal direction and V is for vertical direction. So I have it from 0 to 1. Now every polygon is occupying the whole UV space, and therefore I see the whole picture on every polygon. The logic is to take out every polygon, align them together, and make the whole thing fit within the UV space, so that every polygon would occupy a certain area. Now to do that, I have to assign a different space for every polygon, and to do that I open the unwrap and I click on select face. Now here, if I press F3, I see that I have no seams. The seams are the green lines that I see as indication of a unique UV space. So if I selected this polygon down here and went down and applied a planar map, here I start to see green borders which tell me that I have a unique UV space, so I can move that. And up here I see that I have 2 now different UV spaces, one here and one down there. So I have to do the same for every polygon, so that all of them will be detached and not occupy the same space. Eventually I should have a total of 6. which I have right now. So now I see that I have seams all over, and the seams define, in this case, the borders of the different polygons, which no longer occupy the same space. Now eventually all of them should be placed in this original square here. So I have to scale them down so that they can occupy this. I can either do it manually or I can do it automatically. For now, I'll do it automatically. So what I need to do now is work on the alignment. So here, if I grab a few points, a few vertices, I would see two things. The selected vertex turns red, and the vertex that should be connected to it turns blue. So here I have two blue vertices, which means that these should be connected to that one. Now I can either do it manually, bring these and turn and so forth until I have the proper connection, or I can do it automatically. So if I grab these two vertices, right click and chose stitch selected, these ones are going to automatically go here, turn and stitch to the original. And you see now that you don't have a green line anymore, because the green line indicates a border, but here I have a connection and therefore it turns gray. So eventually everything should turn gray except for the borders of my UV coordinates. So I'm going to continue. I'm going to select these, and this is where they connect. So I'm going to right click and choose stitch selected. If I undo this and selected those in place of these and right click and chose stitch selected, these ones will move to stitch to the ones that you selected. So keep selecting the ones you want to keep. And select these, right click and stitch selected. So now we have this. Of course the box does not go all the way down, because here I'm going to have one and there I'm going to have another one, and you can imagine the way the box wraps onto itself. So this will be the base, this would be the back side, this would be the front side, this would be the top, and this would be the left side, and this would be the right side. So now I'm going to select these, right click and stitch selected, select those, right click and stitch selected. So this is the way a box unwraps. I'm going to now select these. I can either scale them down by choosing scale and scaling down and placing those points here. Of course I have to scale down a bit more. Or another way I can do it is to go to tools and pack UVs, and this will fit the UVs into that space in whichever direction they can fit. So now that I'm here, if I see my picture again, I see now that I have a continuous flow for the polygons over that picture, and no longer I have all polygons occupying the same UV space. Every polygon is occupying a space next to the one next to the neighboring polygon. So now if I press F3 and show the map in viewport, I would see that the texture continues itself across the box. So here we have a perfectly continuous projection of that texture over my box. So this is one purpose of using the unwrap modifier, which is applying a continuous texture for the material of the object. I want now to take that texture to Photoshop so that I can draw over it and see the result update in Max. The first thing I'll do is open back my UV editor, and here I need to take out this portion here and export it to Photoshop so that I can paint over that space. So I'm going to use print screen. The size really doesn't matter, and by scaling the picture up in Photoshop is not going to make you lose any detail, because what you're going to create is the actual detail and not the picture that you're getting. So I'm going to create a new file, paste, and I'm going to crop over this area. I'm going to zoom and make sure that the cropping is as precise as possible. So now that I have it here, I'm gonna merge down the layers and save this as a JPEG. You can also, of course, use PSD. So now that it's saved, I would go to Max and assign this texture into my diffuse channel. Okay, so far I see the lines that I had here. Now I'm gonna restore Max and restore Photoshop so that I have both open side by side. Okay, so there's the image. Now if I use my brush to paint over, save the file, here I'm going to see that I have a continuous flow of that texture over my polygons, which is something that I want, of course. And if I change the colors now and paint over the other ones, save the file, Control S, I'll see that I have it continuous over the other direction. So this is mainly why we unwrap an object, because in case we did not unwrap, we're going to have the texture project over every polygon, which is the default with the box. So by unwrapping, you create a continuous flow for the UV space over the geometry, and that would enable you to place precise textures over the object. So this is one way we can work with it, by going to Photoshop and painting the texture. But of course there are much easier ways, and that would be using a paint program, 3D paint program like Deep Paint 3D or Body Paint or ZBrush, and I'm going to use ZBrush in this case. What I'm going to do next is take the box into ZBrush, and instead of using Photoshop to paint over the surface, which is an indirect way of painting over the surface, I'm going to go to ZBrush and use the ZBrush painting tools to paint over that surface. So what I'll do is choose File and Export, because I have to export the model. And the format that ZBrush understands is the OBJ format. So I'm going to call this, let's say, my box 5, and save. Now here, the things I should choose is group by object. I should uncheck rotate model. The faces should be set to quads, and I should export the textures, normals, and smoothing groups, and that's it. And I press OK. So now in ZBrush, you don't open the file. What you have to do is go to Tool and choose Import, and import your OBJ file. So there's my object, and I'm going to click and create it here. Now it can turn while you create, but by pressing Shift you can constrain this to have a straight orientation. Now next I need to go into the editing mode of that object, so I need to click on Edit. Now if I use the mouse button from the outside, I can turn around it. Now, since I already assigned mapping coordinates for this object in Max, I don't have to reassign them in ZBrush, although I can. But it's best to create your mapping coordinates in your 3D program, being Max, Maya, XSI, whatever, and then go to ZBrush and use those mapping coordinates to create your texture projections. So now I do have my mapping coordinates. What I need to do first is create a texture to paint on. So I'm going to go to Texture, and here I'm going to specify the size of the texture. So I'm going to, of course, the bigger the size, the better the resolution. I'm going to set it to 800 by 800 for now. In case I was working on a character, I would set it to around 4000 by 4000 and even more. And I would click on New. So now I have a blank texture that I can paint with. Now the thing is with ZBrush is that when you paint the way I am now, I have to paint on the vertices. So if I go over here, I cannot paint, although I have my settings set to RGB. And here I have the other settings set to Z-Add, which means that I would deform the geometry of the object whenever I click here. So I'm going to uncheck Z-Add so that I only paint in the RGB space, which is just the colors. Now, in case I try to paint, I won't be able to because I only can paint on the vertices. And this is not the actual painting in ZBrush. What I would be doing here, in case I did paint on the vertex, is just change the color of the vertex. So if I turn and select another color and paint it, I'll be only changing the vertex color. And this is not real 3D painting. What I need to do in order to be able to paint, of course I can decrease. I have two ways here. I can either increase the number of vertices inside my model and then paint over it, and that would give me a nice texture, or I can use the projection master in ZBrush. So I'm going to do the first way first. I'm going to press Ctrl D on the keyboard to subdivide the model, and therefore I have more vertices now. So if I go here and paint with a smaller brush, I can of course do it that way, and then if I press Shift D again, I will still get the same texture projected. So this is one way of cheating around ZBrush to get the texture where you want it. And of course it works. Now the other way would be to use the projection master, and this only works in case you had mapping coordinates assigned to the object. This way works without having to have mapping coordinates because you are coloring the vertices of the object. So regardless of the mapping coordinates, it works because you are changing the colors of the vertices. But here, by using the projection master, which is of course much more intuitive to work with, I'm gonna use my mapping coordinates. So I'm gonna click here, and so far I'm gonna choose to change the colors and to have it shaded, and also use the materials in case I was using a different material here, and deformations. For now I'm not going to apply any deformations, so I'm going to choose drop. So now I have access to many tools that I can use in ZBrush. For example, I can click here and add some iron grain. I can use the different 2.5D ZBrush maps to create those textures. These are not real 3D textures. They are they look like 3D textures, but they are projected in the 2D space. So I can use all of this. I can also paint blobs and change the color and so forth. So once I have this, I would reproject the texture and I would pick it up, and now this texture is projected onto my surface. Now it doesn't have to be a planar projection, so I can go here and project and do whatever I want, and therefore make the thing continuous over my geometry. Okay, so here I was using Z-add to deform the geometry, which I didn't want. It doesn't matter though. So I can reproject back. If I don't choose deformation, those geometry deformation will not be picked up. So I'm going to choose pick up now, and it's still flat. So once I have it like this, I can export it back to Max. So I would choose texture, and I would export it. So here I'm going to name this texture my box 5 and choose save. I don't have to re-export the geometry because it's still the same geometry. So if I go to Max now and apply a material and take that texture, I would have the same projection, but so far it's not the exact same projection, because what I need to do is set the V tiling to -1 so that I would have the same projection in Max as I had in ZBrush, and that would be one way of painting continuous textures over your geometry using an external paint program like ZBrush.